Okay, good morning. So let's start about a little bit. You already read the agenda. I'm going over it. Let's talk about the motivation, the aims, the target. How do we got this RFID passport? How was it developed? What was the design goal? And what's the outcome and the result? And at the second part of my talk, we will have a deep technical view of what was done with all our taxpayers' money. So, any one of you knows this nice guy. His name is Mohammed Atta, famous person in the Western as well in the Eastern world. He unfortunately made two mistakes. One was crashing in the World Trade Center, and the second mistake was done by the US Passport Authority. They gave him a resident visa 12 weeks after he was detected as an attacker and terrorist. So now the government decided to make a biometric traveler identification, and there was a dream from the government how to deal with all the threats and security threats and dangerous people and dangerous travelers. So the government decided to build a multi-biometric double gate. You know why double gate? You can trap them. A double gate with lightly supervised to cut down costs and maintain non-automated entry channels. So the aim is, if the next couple of years Airbus 380 is arriving in Vienna airport and 800 passengers wants to immigrate, you can imagine how long the queue would be. So the idea from the government is, we have an automatic entry gate, so you put in your biometric passport, the system is checking your biometrics, and then the gate opens and you're allowed to get in. And the rest few passengers, they have handwritten passports, potentially from Pakistan or from Egypt, because security in this passport is not so important. All terrorists are coming from Europe with RFID passports, getting through the system automatically. And unfortunately, what's happened, the government just asked first the security print industry and the security print shops. Each European country has, for instance, a company or an agency, mostly owned by the state, who is producing our banknotes and passports. And they actually ask the banknote guys. These print shops are acting on a global basis, so they have a lot of banknote customers worldwide. They have extensive know-how in secure printing, but unfortunately they have no IT know-how. They don't know anything about cryptography, IT security, and they never had done an IT project. So what happened? The print shop asked the smart card industry. And smart card industry, oh, good idea. We have huge amount of technology and see huge potentials. So we can just build something nice. No, just a biometric passport is not good enough. We need to put some value in to sell more of our products. And the result was, the industry came up with an idea for the electronic passport. This passport must have a multi-purpose use. The same design for the national ID cards, but additional, it should be usable for electronic banking, for doing your e-government. You can use it for electronic signatures to encrypt your emails, for email encryption, for travel ID, and as additional as electronic payment. And you can imagine how the result looks like. So, of course, we have to use heavy cryptography and PKI. We have to use biometrics, because this is the main goal of this design. It must be 100% secure against counterfeiting, and improve facilitation, like minimizing time spent on legitimate travelers, segmentation of low-high risk travelers, and minimize immigration time for travelers to give them a benefit. The next thing that's happened is an organization on the global basis, ICAO. This is the International Civil Aviation Organization from the United Nations, came up and set up the standard group. This standard group was stuffed with printing experts and some crypto guys who know something about algorithm. But no one knows anything about implementation, and this design was driven by the RFID manufacturers. No one looked at risks or design goals. You all know this goal, keep it stupid and simple. No, we have to do it complex because it's more secure. The next thing what this group hit was, oh shit, we have patterns. If you want to store your fingerprint, usually it's only one way to store your fingerprint secure. We are building a hash out of this fingerprint. This is easy for fast composition and stuff like that. But unfortunately, all these hashes are patented. So if one country, for instance, Austria or Germany or France, puts in his fingerprint hash, every other country in the world who wants to check your biometric passport has to pay license fees for this country. The next thing is, we have the same problem with our facial image, with a picture on the passport. Why we just don't store pictures like a JPEG or JPEG 2000 or a GIF for the fingerprint? So we don't have to deal with the patterns, and if one country wants to use his own hash, he can get the raw data, generate the hash on site, and make the comparison with the local crime database. Unfortunately, we all know that compromises don't work with security. So now let's have a short look to the e-passport. By the way, I put the source for every of this image, and so most of the images are free and public domain, but some images I have to remove, I cannot put on the website. So as we cite from this nice group, we got an MRTD. MRTD is the name for your new passport. So the next time you want to immigrate and the officer asks you for your passport, you can hand over and him, here is my MRTD. MRTD stands for Machine Readable Travel Document, and also known as electronic passport or e-passport. It was specified by the ICAO and enrolled on a global basis. By the way, who of you guys has a passport with you with this sign on it? So if someone is interested, we can make it secure, we can make a backup after this talk, or look what's possible, and doing nice things. So let's have a short look for the e-passport from Germany, which I actually have with me. This is my MRTD. And you see the tag is embedded in the cover. Inside of this cover is an RFID chip embedded. It actually has 72 kilobytes of memory, a smart card controller, and also this passport chip has a dual interface. Dual interface means it has a USB port and an RFID port using ISO 14443 protocol. There's one alternative method. It's called the 2D barcode for encrypting information on a passport without using RFID technology. This is a Hong Kong passport as example. So they put this significant data as a 2D barcode just under the picture. But not enough space, and the passports are not big enough to put in 72 kilobytes, so they decided to use RFID. By the way, they invented a huge amount of new acronyms. So I try to translate these acronyms to IT speech, because printing speech has nothing to do with IT security, so we have to reinvent the wheel, we have to reinvent all acronyms. So this line, this highlighted line, by the way, can you dim the light a little bit?
There's no such thing as a little bit, it's a hundred.
Just switch it off. Oh. Better? So this highlighted line, it's called the MRZ, or the machine readable zone. So, and this is what you need if you want to visit the States. You only need an MRZ, you only need a machine readable passport. You don't need an RFID passport or a biometric passport. Your passport just needs to be readable by a machine reading this line. And actually, this line contains the data printed on this page in a machine-readable and machine-interpretable standard, also standardized by the ICAO. Now we got the LDS. LDS stands for Logical Data Structure and is something like a directory or format. All data are stored in DGs, data groups, and not in files. But a data group is something similar to a file. The first data group, for instance, is storing the MRZ information. So all information that's printed, this line, is stored as electronic file in the first file as a DG1. The next file is a DG2, and this is your picture. The picture that's printed on your passport gets stored in two possible formats. One is a standard JPEG, and the second one is a JPEG 2000. The next data groups, 3 to 9, are fingerprints, iris image, and these are optional things. Finally, we have an object. It's called security object data and cryptographic signatures. And we have something like an index or directory. So with this file, EFCOM is a list of the existing data groups, something like a directory index. All data is stored in BER encoded data, like ASN1, but it is not ASN1. This is important to know. All the biometric groups, starting from DG2 up to DG9, it's not from, are using CBEFF. This is a common biometric file format. And this is actually a meta format telling you once more, this is a fingerprint with a specific data. So for instance, you have a file that's saying at this place, this file must be a picture. And then you put in a meter format and put in this meter format the JPEG 2000 or JPEG and telling you, oh, by the way, this is a picture. So just to be double clear. There are some security features. For instance, the first versions of this passport has a fixed unique ID. So unique ID is something like a MAC address or something like a device ID. You need to make anti-collision and to communicate with the RFID reader. So at the first passport, you don't need to read the passport. Each one got a unique ID with activation, so you can just track someone else by passing it over a reader, and that's it. And they thought, no, that's not a good idea. They came up a group, they presented a smart bomb, gets activated by a unique ID from an electronic passport. They thought, no, we have to do something against this. This is too obvious to crash and to be dangerous. And after a demonstration showing that in the Middle East, Americans get killed specifically by bombs activated by biometric passports from the States, they thought, no, we have to change something about this. The result was now the actual RFID chips and transponders have a unique serial number, and this serial number gets randomly activated. So for each one, it's something like for each IP packet or for each ARP request, your machine is sending a new unique MAC address. So you are no longer trackable by this machine address. You are trackable and traceable by 100 more things, but this is the first thing that I've stopped. So it prevents tracking without access control. Unfortunately, the ICAO didn't point out that the MRTD requires a unique serial number. So, for instance, some countries like Netherlands and the early Belgium passports don't have a unique ID. So they are easy to track. Next, they invented a method, it's called passive authentication. This method is mandatory for all passports. And this method is for proving that the passport files are signed by the issuing country. So the inspection system has to verify with some sort of technology if the data in your passport is your real data and the data is signed. So the EFSOD contains the individual signature for each data group. The EFSOD is signed by itself, and the document signer public key from a public key directory one part is stored on the passport, and it's signed with a private key, and the public key is available through a public